Why are women more susceptible than men to autoimmunity? Of the nearly 50 million individuals in the United States believed to be living with autoimmune disease, approximately 78% are women. For example, female to male ratio of individuals who suffer from diseases such as multiple sclerosis or rheumatoid arthritis is approximately 2 or 3 females to 1 male. There are 9 women for every 1 man afflicted with systemic lupus erythematosus. However, these statistics do not tell the entire story. In some diseases, such as multiple sclerosis, the severity can be worse in men than in women. Although it may seem unlikely, considerable evidence such as significant gender differences in immune responses. In general, females tend to mount more vigorous humoral and cellular immune responses. Immune cell activation, cytokine secretion after infection, number of circulating T cells, and mitogenic responses are all higher in women than men. Immunization studies conducted in mice and humans show that females produce a higher titer of antibodies than males. This is true during both primary and secondary responses. In transplantation, women also suffer from a higher rate of graft rejection. As one might guess, this enhanced immunity in females means that males in general are slightly more prone to infections. The prevailing view is that sex hormone differences between men and women account for at least part of the observed gender difference in the rates of autoimmunity. Some of this evidence comes from observations made in SLE, where young women of childbearing age are at greatest risk for the disease. Lupus flares during pregnancy and increased rates of remission following menopause also point to sex hormones as potential regulators of this autoimmune disease. The general consensus is that estrogens, the more female-specific hormones, are associated with enhanced immunity, whereas androgens or male-based hormones are associated with its suppression. Why this dichotomy between the sexes? One hypothesis posits that this increased risk of autoimmunity in women is a byproduct of the evolutionary role of women as bearers of children. Pregnancy may give us a clue as to how sex plays a role in regulating immune response. During pregnancy, it is critical that the mother tolerate the fetus, which is a type of foreign semi-allograft. This makes it very likely, maybe even crucial, for successful implantation and fetal development, that the female immune system undergoes important modifications during pregnancy. Recall that females normally tend to mount more Th1-like responses than Th2 responses. During pregnancy, however, women mount more Th2-like responses. It is thought that pregnancy-associated levels of sex steroids may promote an anti-inflammatory environment. In this regard, it is notable that diseases enhanced by Th2-like responses such as SLE, which has a strong antibody-mediated component, can be exacerbated during pregnancy, whereas diseases that involve inflammatory responses such as rheumatoid arthritis and multiple sclerosis sometimes are ameliorated in pregnant women. Another effect of pregnancy is the presence of fetal cells in the maternal circulation, creating a state called microchimerism. Fetal cells can persist in the maternal circulation for decades. These long-lived fetal cells may play a role in the development of autoimmune disease. Furthermore, the exchange of cells during pregnancy is bidirectional. That is, the cells of the mother may also appear in the fetal circulatory system, so that the presence of mother cells in the male circulation could also be a contributing factor in autoimmune disease. Although some studies have linked the presence of microchimerism with certain autoimmune syndromes, other studies have contradicted these findings, casting some doubt on this as a significant mode of induction of autoimmunity.